Welcome back to Aurora Tech Channel. Today, I will review the Creality Falcon 2 Pro with the 40-watt laser module. This is a fully enclosed version of the Falcon 2. The frame of the machine is basically the same as the Falcon 2, but it has a base, a tray, and a top enclosure. So, let's take a look at what we can get from this machine. The machine has a 400 by 415 millimeter working area. It weighs around 18.5 kilograms or a little over 40 pounds. The motion system uses palm wheels on the X and Y axes and dual limit switches on both the X and Y axes. The belt tension can be adjusted using the screws on the X and Y axes. The Z axis uses a thumb screw and a 3-step gauge for setting the focal length of materials with different thicknesses. The bed is a grill-style bed that can be installed in 2 different ways, a vertical position for cutting or laid flat for engraving. The laser module is 40 watts. With this high power, it should be able to cut thicker wood at a higher speed. However, as high-power laser modules generally don't work well for high-detailed photo engraving, it also comes with a small 1.6-watt module, and we will do some tests to compare the photo engraving quality. Unlike most engravers that use standard 20 by 20 aluminum extrusions to form the frame, this machine uses a custom aluminum frame that is more rigid. The electronic enclosure is at the front of the machine, housing the controller board and some standard ports. There's a panel for you to jog the machine, draw the preview frame, and start the most recent job. It also has an emergency stop button, a safety lock, and an air assist pump powered by the motherboard. The LED light and exhaust fan can be switched on automatically when the cover is closed, or you can set them to turn on manually. On the 40-watt laser head, there are 3 sensors to detect the airflow of the air pump, a flame sensor, and a lens sensor to monitor if the lens requires cleaning. This machine is selling for $1,659, which is $340 more than the open-frame 40-watt Falcon 2. Currently, it's bundled with an Ender 3 V3 SE3D printer, so the actual price difference between the Falcon 2 Pro and the fully enclosed Falcon 2 is just less than $200. For this price difference, you get the enclosure with an exhaust fan inducting, a riser base, a grill working bed, and a metal tray. I would like to thank Creality for sending us this machine to review and for sponsoring today's video. And with that, let's get started. The machine came in a pretty large box. I'm not sure if it's fully assembled, but let's find out. The top layer is a metal tray, followed by a few acrylic panels. Then we have 2 laser modules, ducting, an air pump, power supply, and other accessories. At the bottom layer, we have the assembled frame, another 2 aluminum plates for the acrylic enclosure, the cutting table grill, an exhaust fan, and the user manual. As you can see, this machine is semi-assembled. The main frame with the X and Y axis and all belts is all pre-installed. First, I will put together the grill table, and depending on what you're working on, you can put them vertically for cutting or lay them flat for engraving. Then, I will assemble the frame of the enclosure. Slide in 2 panels for the top, use screws to tighten the side panel on the frame, and the screws at the bottom are also used to secure the enclosure to the frame of the machine. Do the same to the left side, which also has an exhaust fan. Connect the 2 cables at the front left. Then, we can connect some external components like the air pump, power supply, and the USB cable to your computer. For the camera, it's basically a webcam attached to the top of the enclosure, so you need to connect another USB cable to the computer as well. Finally, as this machine came with 2 laser modules, a 40-watt and a 1.6-watt, I will start with the 40-watt and connect 1 cable and the air tube. Use the key to unlock the machine, and it's now ready to use. Home the machine to make sure all stepper motors and limit switches are working normally. I set the exhaust fan to auto, so whenever the cover is closed, it will start automatically. Once the cover is open, it stops. Let's go to Lightburn to set this machine up. Go to the devices, and I will just let Lightburn find the machine. Give it a name, leave all default settings, and that's all we need to do. I will start with some simple engraving tests with a 2mm plywood. It came with a gauge for you to set the focal length, and as we are doing engraving, I will use the tallest step on the gauge. Then I will use a lighter material test to engrave some squares on this plywood, starting from 13,000 millimeters per minute to 20,000 millimeters per minute with different power levels. We can only see some minor differences between 13K to 20K speed as the laser module is powerful. Another reason is the squares are tiny. There's not much room for the toolhead to accelerate, so 20K is not much faster compared to 13K when engraving squares at this small size. Next, I will try some cutting, starting from 600 milliliters per minute to 1200 milliliters per minute. As you can see, when cutting at 1200 with 100% power, it can still cut through this 2mm thin plywood, but as the power decreases, some edges are not super clean, but we can still get pretty clean cuts at around 800 to 1000 millimeters per minute. Let's try some 5mm plywood. I will cut it from 700 millimeters per minute to 1200 millimeters per minute. When using anything higher than 900 millimeters per minute, the cut is not very clean, so for 5mm plywood, it would be better to keep the speed at 800 or slower. Let's try some even thicker wood. I will cut this 1/2 inch or 12.7mm poplar wood. I will start with 100 millimeters per minute and 100% power. It drops right off. Then I will try 150 millimeters per minute and 100% power. It can also cut through completely. Then I will try 200 millimeters per minute. It almost cut through, but it requires a little help from me to separate it. So I would say 150 millimeters per minute is the fastest speed for 1/2 inch poplar wood. Then I will try something even thicker. This is a cheap common woodboard from Home Depot. The thickness is 19 millimeters. I will start with 100 millimeters per minute. Then 150 millimeters per minute. Both of them could cut through completely. Then I will try 200 and 250 millimeters per minute. As expected, when we cut the previous 1/2 inch board, 200 can barely cut through, so both 200 and 250 millimeters per minute didn't cut through this 19mm in a single pass. You can see the 200 millimeters per minute one can cut down to around 17 millimeters, and the 251 can cut to around 15 millimeters in a single pass. As this machine came with 2 laser modules, generally, a high-power 40-watt module is good for cutting, but not that good for engraving. So let's try both of them to engrave the same photo and compare the results. I will start with the 40-watt module. From the official website, I found a parameter table. For a 40-watt module, it recommends using 6,000 milliliters per minute with 25% power for engraving on basswood. I will try these settings first. It took 23 minutes and 20 seconds to finish. I think the result is not good. It's too much power, and we can't see much detail from this picture. So I will do 10,000 milliliters per minute with 20% power and see if we can get a better result. It took 19 minutes and 10 seconds to finish. It's better. The picture didn't burn too dark, but the result is still not too good. I will then switch to the 1.6 watt module and start with 3000 milliliters per minute speed and 100% power. As you can see, the 1.6 watt module at 3000 milliliters per minute is moving quite slow. It finally took 42 minutes and 50 seconds to finish. It's a bit light, but you can see the wrinkles on my brother's shirt and all other details on the picture are more clear. As it was already at 100%, I will slow it down to 2000 milliliters per minute to engrave another one. Using 2000 is moving even slower. And the job finally took 61 minutes to finish. However, it's the best out of all four. You can see the 3D printers in the background, while the 40-watt ones are hard to guess what's in the background. There is a precision mode button on the laser head. I tried enabling it, and it seems to decrease the power of the module to about 20 watts. The result is better and in line with other 20-watt laser modules, but the 1.6 watt module still produces the best results. Then I will try some acrylic cutting. On the parameter table, it suggests using 100% and different speeds, starting from 120 milliliters per minute, depending on the thickness of the stock. So I will use 100% and cut from 100 to 800 milliliters per minute. Anything at 600 milliliters per minute or less can cut through this 3mm black acrylic. However, the edges are rough. It seems like the acrylic is burning too much with that high power, but I will still try to use 500 milliliters per minute and 100% power to cut a ninja star. As expected, it can cut through completely, but the edges are rough. Then, I will try only using 50% power and run another test. This time, it can still cut through completely at 500 milliliters per minute and slower. If you put them together to compare, the 50% power ones are much cleaner. So I will use 300 milliliters per minute and 50% power to cut the same ninja star. It looks better, and I would say using a CO2 laser to cut acrylic would be an even better option. It can not only cut dark, but also clear acrylic. But compared to the one cut with 100% power, this is much cleaner. As this machine also came with a webcam that was fixed at the top of the enclosure, I will use Lightburn to do some alignment and test it out. There's no driver to install, as it's pretty much like a regular webcam. After it's plugged in, the computer can detect it. Select Creality Falcon camera. This is a wide-angle camera and not a fisheye, so just select standard lens. Then we have to use the alignment card that came with the machine, move it to 9 different positions, take a picture at each position, and simply follow the instructions from the Lightburn software. After that, we will print a pattern for alignment. Select the fixed type camera. The software is going to engrave some patterns, depending on the laser power to change the speed, power, and your testing material size to set the scale. I will just use the same plywood that came with the machine, so I will scale it down a little to 140 and set the speed to 10K and power to 60%. Let's start the job. Then we need to zoom it in using the mouse and mark the center point of each pattern on all 4 corners. It's basically done, so I will engrave a letter A on the plywood and see if we need to do further adjustments. You can use the webcam to monitor the job, but the angle and the resolution is not ideal for this purpose. Okay, we can now reload the image. It seems the x-axis is almost perfect, but we still need some adjustment for the y-axis. Setting the offset to 1.5mm would be perfect. I will now use the rectangle tool to draw a baseline under the letter. Let's see if it can align perfectly. It's not far from perfect. I would accept this less than 0.5 mm off, as this is probably the best a wide-angled webcam can do. To test out the accuracy in real life, I will engrave a logo on this credit card-sized coated aluminum business card. I will try to place the logo as centered as possible on the x-axis. Let's start the job and see. I think it's still off by 0.5 to 1 mm, and it's fallen within the acceptable range of using a fixed webcam. Another reason is the preview captured image in Lightburn is not clear, so I would say it's much better than using the preview frame to align it with the laser module. Finally, I will also use the camera to align with this round slate. I will position the pattern at the center. It will engrave from edge to edge. This is the best I can do to position it at the center. The result is pretty good, and I have no complaints about this slate. The engraving was done perfectly from edge to edge at the center. Okay, let's talk about the pros and cons of this machine, starting with the pros. 1. The powerful 40-watt laser module. It can cut 5mm of plywood as quickly as 1000mm per minute and 90mm of wood at 150mm per minute. The cutting power is impressive. Since most high-power laser modules can't deliver high-detailed photo engraving, it also comes with an extra 1.6-watt module, which does a much better job at photo engraving, although it requires much more time to finish the same job. 2. The power of the air assist pump is connected to the electronic enclosure, allowing you to control it using G-code. This feature lets you turn off the air assist pump when engraving and turn it on when cutting. 3. The cable management is excellent. The laser module and air assist tube are well organized using metal clips. The frame is pre-assembled, making the setup quite easy, although you still need to assemble the top cover frame and slide in some panels. 4. The electronic enclosure is packed with all the expected safety features. It includes an emergency stop and a lock. Additionally, the 40-watt laser module has a flame sensor, an airflow sensor, and a laser lens sensor. 5. The camera is fixed to the frame, unlike other add-on cameras with mounts that require recalibration if bumped and move slightly from the original position. 6. The enclosure of the machine is compact, with sliding panels that work quite well. It saves space and includes 2 sensors to control the exhaust fan and LED light. All the small details on this machine are better than average. Now for the cons. 1. The camera is essentially an external webcam. Aside from being fixed at the top, it is no different from just adding a DIY webcam. You still need to connect another USB cable to your computer for it to function as a webcam. The accuracy of this camera is comparable to that of a DIY webcam. 2. The metal tray is painted black. To protect it, I have to put another steel plate on top. However, if the engraving or cutting area extends beyond the steel plate, it will mark the tray as well. Without any protection, the tray will become quite messy after a while. 3. The motion system uses palm wheels, which are slightly different from the palm wheels used on 3D printers as they have a slot in the middle. They appear more stable than regular palm wheels when moving at high speeds. However, using steel wheels or linear rails would be a better option, especially since this machine is supposed to run at high speeds most of the time. 4. The engraving and cutting parameters on the official website don't seem very accurate. For example, when I followed the table to cut acrylic and engrave a photo on plywood, neither produced good results. I suggest that Creality could manually verify that table, as it could be super frustrating for beginners. In conclusion, if you're looking for a laser engraver, choosing the Falcon 2 Pro instead of an open-frame machine that requires an extra enclosure, an exhaust fan, and ducting, accessories like a webcam, honeycomb bed, air assist pump, it offers a hassle-free full package, potentially at a lower overall cost. The build quality is high, and the small details are well polished. There are minor drawbacks such as the machine not being fully assembled and lacking its own control software, but they're not deal breakers. If you have some experience with laser engraving, you could probably assemble this in about 20 minutes, and you possibly already have the Lightburn software. So you will likely appreciate this machine, especially if you're upgrading from an open frame 5 to 20 watt laser engraver. So, if you're interested in the Falcon 2 Pro 40 watt machine, I've included links to it as well as the 60 watt version in the description. You can also visit my website auroratechchannel.com, which tracks prices and offers recommendations for over 150 popular 3D printers, laser engravers, and desktop CNC machines. That's it for this video. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.